Welcome back to another episode of the Sprinkler Nerd. In this video, you are going to learn how to use a soil moisture sensor to automate a program using lower threshold on the baseline BL-1000 controller. This was recorded from a live training call with an irrigation consultant and a project in New England. Let's jump right in and take a look. Okay, are you seeing my screen?
I can, yes.
All right. So then I'll open up Base Manager, and is this in your account?
It is, yep.
Okay. And is this Williams? Okay, perfect. Good. So talk to me about how they want to set this up or how you want to set it up for them.
Well, so we just got them to add 2 soil moisture sensors per our plan. 2 more, I should say. So they had 2. We asked for them to provide 4. The one thing that I started doing on my plans that that on this one I hadn't done yet, but going forward on my plans will be shown, is identifying and numbering the soil moisture sensors on the plans. And then also when we call out zone valves, we're calling out program numbers, program and valve numbers, as well as the representative soil moisture sensor to use. So going forward, that's something that we've done on our end to help the team program, or the installation team program these controllers going forward.
Okay.
So what I did here was, instead of just saying MS1, 2, 3, 4, I added the description just to say south lawn, north planter bed, west landscape, east landscape. So I set that up as far as it goes there. So the idea is that we have 14 zones. Let's see what I have here. Let's call this up here. I've got 14 zones, and I know which zones that I want to add to which soil moisture sensor. So that's where we're at right now.
Okay.
Yeah. So basically, yeah, we just need some help walking through that.
Yep. Okay. So let's just look at it, a basic idea. So why don't we make a list of like say the first grouping of zone numbers and then which corresponding sensor. And I'm just going to make a note here on my desk.
Sure.
Yeah. So let's say just list off a couple sensors that you want to be controlled by the same.
Okay.
A couple zones you want to be controlled by the same sensor.
Right. So let's start with zones 1, 2, 3, and 4. I want on soil moisture MS3. So MS3 should go with 1, 2, 3, and 4.
Okay. So what we're going to do is make a new program.
Okay.
Just going to go through the process here. And is there a particular name you'd want to call this program other than maybe zones 1 through 4?
I would call it just let's call it north planter bed, or north planter beds.
Beds. Okay. So what we're going to start with is we got to get these zones in here. And so I'm going to start adding a zone, and you said zone 1.
Yep.
Perfect. And we can add the run times later. And then we're going to add zone 2.
Mm-hmm.
We're going to add zone 3. We're going to add zone 4.
Yep.
And just for the sake of, sometimes I like to sort of save our settings right away in case, something happens with our internet connection, etc. So now we have this program created and our zones are in it. And now we can go ahead and put some run times. So, which will bring up our discussion about the sensor. The sensor can either turn the system off when it's wet or keep it from watering until it's dry. And I would tend to recommend that option. And in that way, you can set a runtime that makes sense for your water window, as well as just plant health in general, based on the type of irrigation. So let's go ahead and set a runtime that would be between a 1/4 inch and a 1/2 inch of water.
Right. So I would say for this planter bed, I would say, we probably need, I would say let's set it for like 10 minutes. It's probably,
Okay.
for that one, for zone 1, let's say it's 10. I actually think they all should be about, based on the precipitation rate, it should be about 10 minutes.
Yeah, and you could tweak this later. So the nice thing is you can take a look at once this starts running and sort of see what is 10 minutes actually accomplishing here. Are we putting enough moisture down? Is it raising the content? Is it not? And we can make adjustments from there. Okay, and then the way the sensor works with the 1000 is it's going to control this program, which is different than on the 3200. We can assign the sensor directly to one zone and call it a primary zone and have the sensor operate the zone. And on the 1000, it controls the whole program. Right. And so what that's considered is a start condition.
Yeah.
So what we're going to do is we're going to add a condition. And we're going to delete this condition, the first one, which is just a timed, see up here, timed condition.
Yep.
So we have this start condition.
Okay.
And we're going to find the sensor that you mentioned, which is MS3.
Correct.
Okay. And for right now, I think what we'll have to do is go look at sort of the history of the sensor. And so right now, let's just set it at 25%. We'll go take a look and we'll come back and readjust it. So, but what this is saying is that it'll be allowed to start, because it's a start condition, if the moisture sensor is less than 25. So it's going to wait till it gets to 25 before it's allowed to water, or whatever we decide to set for that threshold.
Right.
And then if it meets this condition, then it will start at a time of day, so there's some certainty. Okay, the regular start time. So what do you want to put here for a time of day?
They started zone 1 at 10 p.m. So let's start it at 10. So it's consistent with what they've already put in there.
Okay, and then of course this is the optimum schedule, meaning every day. So if it goes dry now below 25%, it'll start tonight because it's Tuesday. So it'll always have a chance to start. But if there are certain days you don't want it to water, we can turn them off.
Right. Yeah, I would say we should go just do it every day for now.
Yeah, and then the days will change. So as we go into fall, it might only water once every 3 days and then maybe once a week. And then it'll never hit the threshold because it'll stay moist.
Right, exactly. Great.
Yeah. And then we've got our water window. So this is allowing it to water any time of day. And again, 4 zones starting at 10 p.m. I don't think we have to worry about this water window. 1 zone at a time. We've got water source 1. Okay, so that looks good. So I'm going to just save this. Then we'll take a look at the moisture graph, and then we'll come back and tweak the threshold. Which specific zone is this sensor buried in? 1, 2, 3, or 4?
I believe it's in zone A1.
Okay, zone
or in 1.
1.
Sorry.
Okay. Come on, internet, let's load. Well, let's just see if it saved it or not. Remind me of the connection type that they ended up with out here. Was it cellular?
No, it's Ethernet.
It was, okay. Set this again. It didn't save on us. I'm going to add the condition. MS3, we'll put 25% as a placeholder. Okay. So now let's go and run a report. Actually, first, before I do that, let's look at our sensors and enter the assignment. So on MS3, if we edit the sensor, Yep, assigned to zone 1. Perfect. we're going to do the one that I like to look at is the zone runtime, because it allows us to just see the watering and the moisture. So we'll look at zone 1 and the sensor, and I'm actually going to just put this at a 1 month window.
Okay.
Okay, which we can see that this sensor was installed on August 23rd, because we've got no data before that point.
Right.
And it was drying down, and then we have a nice watering cycle here, which is great that we can see it. So it's installed, I would say, correctly. And then we've got another here, which this to me would represent rain, because I'm not seeing
Correct.
a runtime.
Right.
Okay, so now next thing I'm going to do is sort of zoom in a little bit closer. So when we see these spikes, this is saturation, because the soil is not able to hold that water.
Right.
But once we see this sort of dry down, we might say something like, okay, maybe field capacities, right in that 27% range. Okay, so that would be wet, 27%.
Mm-hmm.
So if we wanted to calculate an estimated dry time, which is, of course, subjective to plant health and root depth and all these other things, that a general rule of thumb might be to subtract 10 to 20% of this number.
Okay, right, which makes sense.
Yeah, so 10% of 27 is 2.7, right? Yeah. So, and then 2.7 times 2 is, just above 5. So I would say maybe we drop it down just to be safe, like 4 percentage points.
Yep.
So 27 minus 4 percentage points would be about 23. Mm-hmm. Right now we're at 25. And so that's what we'll do, is we'll go back into the program. And we'll set this at 23 as the dry line.
Great.
And if everything works correctly, we should see that green line change for us. Moisture sensor 3, zone 1, and let's do the last 14 days.
There it is.
There it is. And so right now we're operating above the threshold, so the system will stay off until it dries down to that point. If we feel like it's going too long and it does need to water, then we can bump this threshold up.
Yep, got it.
And when the plants are under high stress, like in the summer when they're not, depending on the health of the plant, if it's under high stress, it may not be able to sustain as low of a threshold because the plant's just not healthy or the roots aren't at the right depth, et cetera. So it could be that in the summer we have to raise it, to provide extra water.
Absolutely. Yep.
Great. So that's the basic rule of thumb that we use to set it up. I think having 2 or 3 weeks of data is awesome. And while we're in here, let's just go take a look at your other sensors. And actually, let's make a couple quick changes. So if I were to add additional labels to these sensors, I think what I find helpful is also to add something on here like that's in zone 1.
Okay. Absolutely.
Yep. And let's just kind of go through these. MS1, what zone is this in?
Yep. And that would be that's in zone 9.
Okay. And then this guy.
West landscape is zone, I believe it's zone 7.
Okay. Oh, here, I should be changing this also.
Yep. So yeah, I should probably go back to the other one.
Yep. And this final one?
Zone 12.
Okay, so now that they're labeled, just makes it a little easier when we run the reports.
Right.
To take a look at sensor that's in zone 9 and then the runtime on zone 9. Okay, so zone 9 hasn't run, and that's the rain event. Let's just bump this out because I'm curious and see what it looks like for the month. So yeah, we did have a little bit at the beginning of August and it hasn't run since. And let's check out zone 7. Yep, this must be rain too, but I don't remember seeing these rain spikes on the other sensor. So maybe.
Some of them have, they could have tree canopy over them so that they're not experiencing the same rainfall as they would, let's say, in an open area. So.
Right. And this is a good way as well. If you see something that doesn't quite make sense, it could be that what you thought was in the sensor you thought was in zone 7 is actually not.
Exactly.
And let's check the last one.
Yeah.
Yep, that's all good. And so this one, probably somewhere in your middle of the curve. This one doesn't quite hold as much water. The soil's a little bit different, or it's not packed as tightly, things like that.
Right.
Yeah, so that's the kind of the concept, is to put the zones that are going to be controlled by one sensor into a program and then use the sensor setting on that program.
Right. Oh, that's fantastic.
And then what I would do is just come in here and we should delete out zones 1, 2, 3, and 4.
Right.
And we could, depends how much detail you want to put in here. You could say something like,
right,
so that you can remember. And if you hover over program 2,
right,
it'll remind us. Oh yeah, that's zones 1 through 4, which is displayed here. But in any case, that's the strategy. And the fun part is once you set it up, then you could look at it. I mean, really just 5 minutes every other day or once a day, and you can start to see, what's happening on this site. And it's kind of interesting.
Yeah, it is very interesting. I mean, I did a lot of my own, master's thesis in this type of stuff. So it's actually nice to actually see a lot of this stuff, used in practice, and you can see it firsthand how the soils are reacting to irrigation and rainfall. So,
right.
Yeah, I think from our perspective too, probably the next step, if we were to go forward, when we specify more of these products, would be to, to add like an on-site tipping rain bucket, so we can compare and contrast, just so we can see what rain has fallen on a specific site versus and compare it, so you have a pretty good idea of how soils will respond to both irrigation and to rainfall. But yeah, no, it's great stuff.
Right. Yeah. You can get kind of close, meaning if you had a weather station on site, right, you could connect it to the W underground. And of course, if you don't, you could find something close by, which won't be exact, because rain can fall and not fall in certain areas. If you have a second, I'm just going to take a quick look and see
I'd be
where the closest weather station is to that. Let's change this up. And this is what, remind me of the city?
It's Williamstown.
Williamstown,
all one word.
Right.
Mass, yep.
Okay, so then if we hit the change button, we'll see all the weather stations here. So based on where the school is located, got a hunch on which one of these is closest to the site? Williams College Environmental Center?
Yeah, that's probably, I'm guessing that's it. Yep.
Yeah, okay. And then up here in the URL, this is the station ID that's associated with it. So if we copy that station ID, we come back to Base Manager. We can add that ID here.
Cool, that's really neat.
Yep, as long as it collects all the criteria, including rain, that we need, it can be added. So now we have that added. So when we're in Base Manager, we've added that. So what we can do is come down to Weather Station, assign a weather station, and then there it is.
Perfect. Great.
So really, unless you're automating it, the benefit is it'll be right here. So in a couple hours, we'll get the daily ET, but now we have a quick way to click over to it and let's say review the rainfall and look at the data. So yeah, you could roll this back and
Sure.
compare it to periods of time and what did the moisture do after the rain and such. Yeah.
Very cool. Very cool stuff. Yeah. No, I think this is great tool, Andy. No, I appreciate walking me through it. So I think I can help these guys out for the most part. I think setting this up. So just the last question I have, I guess, as far as the master valve goes, you know, I think 95% of most master valves are normally closed. They have it as normally open, and we have a commercial now. We just have a regular Hunter IBV that we're using as the master valve. So I think what they're doing is they're bypassing. I'm guessing what they're doing is they're bypassing, or maybe they just didn't. And I've gotten confused in the past too between normally open and normally closed. What if those sensors, if those settings should be, you know, if we should change those settings to make sure that the master valve is closing on the abnormal flow.
Yeah. So so not every, I'm trying to think, Hunter, not every valve can be normally open. I'm not entirely sure Hunter has a normally open master valve.
The only one that does is, well, I think Toro has one.
Yep. Irritrol.
Yep. What's that?
Irritrol has one.
Irritrol has one. Toro has one. And the ones we've been trying to spec a little bit more these days is actually Griswold.
Okay.
You know, when you start, and you're getting into higher end valves. But yeah, for Hunter and Rainbird, they don't have normally open valves. So.
And this is a Hunter valve?
It is, yes.
Okay, so it has to be normally closed. Even though they've checked it for normally open, I think you're right. They've mechanically opened the valve to keep it open all the time.
Right, exactly.
So it won't be able to close or work as a master valve because they've mechanically bypassed it. And in this case, the only way to make it work is to keep it in the normally closed mode.
Right.
So that if it is open and there's a high flow, it would shut down.
Right. Right.
And the question would be, I wonder why they're bypassing it. If they have quick couplers or something else that we could maybe work around to meet their needs while allowing the master valve to be used.
Well, the only thing that we've thought of in the past is, you know, when we have quick coupling valves, we generally have them anyway. We have other temporary landscape out here, so not everything out here that's landscaped has permanent irrigation, so they do need quick coupling valves. So it could be that they're just letting it stay open. The problem with that, like you said, if we have a catastrophic break, or if we have something in the line that's, you know, a leak or a break, that master valve won't be able to close because it's running as though it's normally open, so it's not going to do what we think it's going to do. You know,
right?
Again,
it won't do anything at this point. Right.
And I think we've seen some of these issues in the past too, where, you know, we normally closed valves are the ultimate fail-safe for systems with domestic water systems. When you have a pressurized water supply, that a normally closed valve is the way to go, because if there's an issue, then it just shut you cut power to the valve, and then the valve closes. But where we do have master valves, we've trying to spec more normally open stuff, especially for like rainwater harvesting from areas where we have a tank, only because, you know, there's no pressure. We're supplying our own pressure, so whether if there's a break, it won't matter because it'll only flow water during an irrigation cycle. There isn't a direct connection to the pressurized street or some other pressurized source. So, from that perspective, if there's a way to, let's say, either treat the master valve as like a dummy zone during the day where it's open and then it's closed, where it stays open during the day for hand watering, but then it closes after, let's say, 5 p.m. so that it operates like a real normally closed master valve for an irrigation cycle. That's kind of what we've come up with ideas in the past. We've had dummy zones in the past too. We're just adding a dummy zone for just quick couplers, but we would think there would have to be a better way to just from a normally closed perspective to basically just energize that master valve to keep it open during the day and then closed at night.
So I was going to double check this. So this is what I wanted to see. At the controller, so you can either be at the controller or if you're logged in, with your phone into the base manager view versus mobile access, there is a run master valve option. Mm-hmm. So you could turn this master valve on for a period of time, 10 minutes, 30 minutes, 2 hours, but it's not on a schedule. It would just be a manual run master valve. And
okay.
Double checking to see if, yes, we can do it here as well.
Okay.
Just not from the mobile version.
Got it.
Or on a schedule. Let me just check one other thing. I don't think we can add a master valve as an irrigated zone. No.
Oh.
Right. So for it to be on a schedule, we need an actual zone. Otherwise, it's just going to be a manual run.
Well, I mean, that's not the end of the world either. I mean, I think that if whoever's managing the system has the mobile app, if they just turn they can just turn the master valve on, right? That's what we want. Or
come over to the controller and go to manual run and turn it on for a period of time.
Right.
Yep.
Or just run the master valve and just say run it for 2 hours while I'm hand watering.
So that's what I'd recommend, is that they set the master valve up as you designed, normally closed, mechanically make it right, set up your high flows, unexpected flows, et cetera, and then manually run the master valve if they want a quick coupler.
Right. Okay. I mean, I think that's the safer way to go too, just in terms, because if they've had leaks, let's say they've had leaks all 24 hours a day, at the very least, then that leak isn't happening 12 of those hours a day or 10, you know what I mean? Like, at least you're cutting that loss, that water loss. Not that it's acceptable, but it's more acceptable than just letting an uncontrolled 1, 2, 3 gallon per minute leak persist for 24 hours with a normally closed valve that's open all the time.
Yeah.
So, Okay. No, that makes sense. All right. Cool. No, this is great stuff. Thanks, Andy.
Yeah, no, it's good for me as well to just get eyes on real sites. It's helpful.
It is, and I tell you, it's good to know also that the theory of how we design our systems, I mean, better than I do, but we design our systems based on the theory that's available to us. So it's nice to know that the theory is actual in practice, and that we can implement what we theorize for water conservation. We can implement it in actuality, as opposed to trying to do without or have less functionality with some other controllers. So no, this is great.
Yep, and we'll probably talk about it next week. But we hope that having these tools keeps you in communication with your customer versus specifying it, designing it, and then being done as an irrigation contractor, does whatever they're going to do. If you can stay in communication with your client because you've got access, now they can keep coming back to you and you can be eyes and ears versus just being, done with your project.
Absolutely. And I think there's a real, as I think there's a market for that from our perspective too. So it'll be good to learn more next week and kind of seeing what's coming, what's available now, and, what we can do going down the road to add more features or streamline things. So
yeah, awesome. Cool, Great. Mike. Well, have a good afternoon.
We'll see you next week, Andy.
Okay.
Bye.
Yeah. Bye.